This is day 11 of Unit 5. We started today with a warm-up, so pause the video, take a moment to work on the warm-up. So number one, I can factor out a GCF, and then I'm left with difference of cubes. So there's number one. Number two, I have a trinomial and I don't see a GCF, so that means two binomials. So I know to get x to the fourth, I need x squared, and to get 6, I know I need either 3 and 2 or 6 and 1. So I'm going to try 3x squared and 2x squared. And to get y to the 8th, I know I need y to the 4th and y to the 4th. I also see that the y to the 8th needs to be negative, so one of those y to the 4th needs to be negative. I'm going to determine which one here in a second, because in the middle I need a positive x squared y to the 4th. So that means the 3 needs to be positive, positive 3x squared y to the 4th, and the 2 needs to be negative, because 3 minus 2 is 1, positive 1. So I think that's correct, and it doesn't look like I can factor any of those any further, so that is my answer for number 2. Next, so we started our lesson with synthetic division, just like we did yesterday, except for now we're using complex roots. So I'm going to start off with 2i as my root, and I'm going to write the coefficients here, remembering to fill in zeros if there's any missing terms. Doesn't look like we're missing any terms. I am going to spread these out quite far because when you have complex roots, you need a little bit more space. So 1 is my first coefficient, and then -2, and then +5, and then -8, and then +4. So the 1 comes down, times 2i is 2i. -2 and 2i are not like terms, so I can't combine them. So now I'm going to do 2i times -2 plus 2i. So I'm going to take that one term at a time. 2i times -2 is -4i, and 2i times 2i is +4i squared. Well, +4i squared is equal to -4, so I'm going to write that below the 5, and then I already said the -2 times 2i was -4i. So next I'm going to add, so 5 minus 4, 5 plus -4 is 1 minus 4i. So now I'm ready to do 2i times 1 minus 4i. Well, we'll do the 2i times the -4i first. So that gives me -8i squared. -8i squared simplifies to +8. And then I'm going to do the 2i times 1, which is plus 2i. So the 8 and the -8 cancel out, and I'm left with 2i. So I'm going to do 2i times 2i. Well, that's 4i squared, and 4i squared simplifies to -4. So I'm getting my remainder of 0, which I expected because I was told that 2i was a root. So now I'm ready to continue on. Well, what we did yesterday with synthetic division was we used these numbers here as our coefficients for the polynomial that's 1 degree less. Well, that's cubic, 1 degree less, and those will be our coefficients, and they're pretty yucky complex numbers. I don't really want complex coefficients. So the way that we avoid having to solve a cubic with complex coefficients is we actually know something else about the roots. You think back to earlier in the unit, if 2i is a root, then so is its conjugate. Because we talked about complex roots come in pairs. So if 2i is a root, then automatically we know that -2i is also a root. So what we'll do is we'll run through synthetic division a second time with the conjugate, and we'll use these numbers in our synthetic division. So I'm going to put my equal sign below those numbers, and I'm going to run through synthetic division a second time. So 1 comes down, 1 times -2i is -2i. The 2i and the -2i cancel out, and I'm left with -2. -2 times -2i is +4i. The i's cancel out and we're left with 1. And 1 times negative 2i is negative 2i. And that combines to 0, which we expected. So we've just confirmed that x equals positive 2i and negative 2i are roots, which we already knew that, but we've confirmed it. But more importantly, because we ran through synthetic division twice, now we have 2 degrees less than the original dividend. So that would be x squared. So I have 1x squared minus 2x plus 1 equals 0. So I'm going to now solve that. It looks like that factors. So we know x minus 1, x minus 1. So x equals 1. And also the plus minus 2i. So 3 roots, 2 of which are complex, 1 is real, and its degree 4. So it almost looks like that we're missing 1, but remember this 1 is a double root. It occurs twice, so we count that as two roots, and then the 2 complex, we have all of our roots. Oh, should go back a second. I just want to point out the second time through synthetic division with the conjugate should always be much easier than the first time through. And your coefficients, after you've gone through 2 times in synthetic division, your coefficients should be real numbers after the second time through. If you're getting any complex or imaginary numbers here, then you know that you did something wrong, because you should be ending up with nice real numbers there the second time through and 0 remainders. So let's try this one. So 2 plus I is my root. Again, spread out your coefficients, 1, and then negative 3, then negative 3, then positive 21, then negative 20. So 1 comes down, times 2 plus I is 2 plus I. Negative 3 plus 2 is negative 1 plus I. We're going to multiply that by 2 plus I. So I have a binomial times another binomial. I'm going to set up a small generic rectangle to do that. Negative 1 plus I times 2 plus I. And again, if you don't want to use generic rectangle, then distributive property. So 2 times negative 1 is negative 2. Negative 1 times I is negative I. I times 2 is 2I. And I times I is I squared, which is negative 1. So when I combine like terms, negative 2 plus negative 1 is negative 3. And 2I minus I is 1I. So negative 3 plus I. And then add gives me negative 6 plus I. So I'm going to multiply negative 6 plus I times 2 plus I. Once again, I'm going to make a little generic rectangle to help me with that. Negative 6 plus I times 2 plus I. Negative 6 times 2 is negative 12. Negative 6 times I is negative 6I. I times 2 is 2I. And I times I is I squared, which again is negative 1. So negative 12 plus negative 1 is negative 13, and negative 6i plus 2i is negative 4i. So negative 13 minus 4i. So 21 minus 13 is 8 minus 4i. So I'm going to multiply that by 2 plus I. Now, I know to expect a 0 remainder, which means I know to expect 20 here. But you don't want to just fill in 20 and assume that everything you've done so far is correct. You want to actually do 8 minus 4i times 2 plus I, because you want to confirm that you get 20, which tells you that you're on the right track and that all of these numbers are correct. So don't just fill in what you know it should be, actually do the multiplication, because that serves as a check to see if everything you've done so far is correct. So 2 plus I times 8 minus 4i. So 8 times 2 is 16. Negative 4i times 2 is negative 8i. 8 times I is 8i. And negative 4i times I is negative 4i squared, which equals positive 4. So 16 plus 4 is 20, and the 8i and the negative 8i cancel out. So we indeed did get 20, which confirms that 2 plus I is a solution, because we got that zero remainder, but it also tells us that everything we did before that was correct, because we did end up with positive 20. So now I'm going to run through synthetic division again with these numbers and the conjugate 2 minus I. So 1 comes down times 2 minus I is 2 minus I. The i's cancel out. 2 plus negative 1 is 1. 1 times 2 minus I is 2 minus I. The i's cancel out. Negative 6 plus 2 is negative 4. Negative 4 times 2 minus I, so distribute. Negative 4 times 2 is negative 8. And negative 4 times negative I is positive 4i. So we indeed got what we wanted, zero remainder. We confirmed that 2 minus I is a root. And we're now 2 degrees down from the original dividend. So we know that this is quadratic. X squared plus x minus 4 equals 0, which looks like it doesn't factor, so we're going to have to either complete the square or use the quadratic formula. I'm going to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 1 plus or minus the square root of 1 plus 16 all over 2 is negative 1 plus or minus the square root of 17 all over 2. So we have two solutions there, and we have our two solutions that are complex. Remember, now these here, negative 1 plus minus square root of 17 over 2, those are real numbers, okay, because I don't have an I. Those are just irrational. So if I was looking at the graph, I'd see it crossing at two different spots. They'd just be decimal values. And then I would see that U shape from the two complex solutions. Next, so we're going to try negative I root 3. And our coefficients, doesn't look like we're missing any, but do remember to include the zeros if you are missing any. So 1, negative 1, negative 3, negative 3, and negative 18. So 1 comes down times negative I root 3 is negative I root 3. Those are not like terms, so negative 1 minus I root 3. So I'm distributing negative 1 minus I root 3 to negative I root 3. So I'm going to write that out. Negative I root 3 times the quantity negative 1 minus I root 3. So let's take that nice and slow. We're going to do negative I root 3 times negative 1 first. A negative times a negative is a positive, and 1 times I root 3 is I root 3. Now, negative times a negative is a positive. Root 3 times root 3 is 3, and I times I is I squared. So let me simplify that. We have I root 3, and 3i squared is negative 3. So we have I root 3 minus 3. Or if I rearrange that so the real numbers first, we have negative 3 plus I root 3. So that combines to negative 6 plus I root 3, which we're going to multiply by negative I root 3. So once again, we have a binomial times a monomial. So I'm going to write that out. Negative I root 3 times the quantity, negative 6 plus I root 3. So I'm going to distribute that one at a time. Negative times a negative is a positive. 6 times I root 3 is 6I root 3. Next, positive times a negative is a negative. Root 3 times root 3 is 3, and I times I is I squared. So that simplifies to 6I root 3. Negative 3I squared is positive 3. And again, if I rearrange so that the reals first, I put 3 plus 6I root 3. So the 3 and the negative 3 cancel out, and I have 6I root 3. And I'm multiplying 6I root 3 times negative I root 3. Once again, I know to expect 18, but let's make sure we get that. 6i root 3 times negative I root 3. So a positive times a negative is a negative. 6 times 1 is 6. I times I is I squared. And root 3 times root 3 is 3. So that gives me negative 18i squared. And that simplifies to positive 18. So we got the 0 remainder, which means that negative I root 3 is definitely a root. So now let's run through with the conjugate, positive I root 3. One comes down, times I root 3 is I root 3. The i's cancel out and I'm left with negative 1. Negative 1 times I root 3 is negative I root 3. The i's cancel out and I'm left with negative 6. Negative 6 times I root 3 is negative 6i root 3. The i's cancel out and I'm left with a 0 remainder. I just confirmed that positive I root 3 is also a solution. And I'm left with a quadratic. X squared minus x minus 6 is equal to 0, which factors. So x minus 3 and x plus 2, which means that x equals 3 and negative 2. Those are the real solutions, real roots. And then I have the 2 complex, which total 4, and it was degree 4. So your homework is pages 20 and 21 in your Unit 5 packet.